So our learning goal today is I can solve an equation in one variable. So we're back to just one variable equations. We don't have all those extra letters, all those extra variables in it. So we're back to solving equations that have just one variable in them. The tricky part today is that it has an absolute value expression in it. We have not done anything with those yet. Do you have any prior knowledge of absolute value? You know what I'm talking about when I say absolute value? 7th grade, 8th grade, they cover that at all? No? Okay, so it's new to us. Okay, so basically what absolute value, first of all, the important thing that we need to, I want you just to circle this right here. That's the symbol that means absolute value. So when you see these two vertical line segments on either side of an expression, that is read absolute value of. So we say the absolute value of something, and what it really means is we're looking for whatever's in there, what's its distance from 0 on the number line. Absolute value means how far is it, what's its distance from 0 on the number line. So this first example here, where we have absolute value bars around the variable x, this is really saying the absolute value of x equals 2. And what it's really asking is, which numbers can x be that are 2 units from 0? What could you put in place of x that when you're done putting it in there, you would say, oh, its distance is 2 units. So can you think of any numbers on the number line that are 2 units from 0? 2 isn't 2? And so is negative 2. They both are 2 units away from 0. One's to the right of 0, the other one's to the left of 0. But they're both 2 units of distance away. So we would say the solution to that equation, the absolute value of x equals 2, is x equals positive 2 and x equals negative 2. We have 2 solutions to that equation. So typically up to this point, we've only had one solution. There are going to be times when we're solving these absolute value equations that we will get 2 solutions. Okay, so let's practice some. That first one says the absolute value of x equals 7. So in other words, it's saying, what could you put in there for x that if you replaced it with what you believe it is, it would have a distance of 7 from 0. Negative 7 would work. Okay, so we would say x equals negative 7 because it is 7 units away from 0. Are there any other numbers that are 7 units away from 0? Positive 7 is also. We have 2 solutions again because we have both of those numbers that are 7 units away from 0.
So it says the original is x equals 7.
Oh, no, that is, but the original says that, but in our solution we should no longer have absolute value bars. So if we just said that's already solved, we would have only had one solution, right? But this really actually has 2. Okay, how about our next one? Go ahead and write down what you think the solutions are for the next one, number 2. What do you believe the solution or solutions are for number 2? Do it on your own. Volunteer to share with me what you believe the solutions are for this one. Adam?
A positive 12 and a negative 12. So x equals 12, x equals a negative 12.
Okay, so x equals 12, and you say that x can equal negative 12? So in other words, if we put 12 in here, we would say 12 is 12 units away from 0. If we put negative 12 in here, we would say how far is negative 12 from 0? It is also 12 units. Are there any other numbers that are 12 units from 0? No, there aren't. So there are these 2 solutions. Okay. Hopefully that's what you got. Hopefully that's what you got. Good job. How about the next one? That one's saying, what could x be that is 0 units of distance away from 0? Just 0, right? Yeah, there's only one number, and that's 0 itself. That is 0 units away from 0. So this. Okay. How about our next one, number 4? X equals the absolute value of x. In other words, the distance of x is negative 5.
You could have another and then positive 5. Negative and positive 5.
Kind of like there to stump you. You know what? We don't ever talk about distances negative. In other words, if you, let's say, you live out in the country and you have kind of a long driveway, and that particular day, it was easier for you to back out of the driveway somewhere. So you back out of the driveway and, say it's a distance of like 4/10 of a mile. Would we say that you went a negative 4/10 of a mile because you were backing up?
No.
No, we wouldn't. We talk about distance always in positive. There isn't such a thing as negative distance. So in this case, when we have this, we cannot find a number for x that has a negative distance. There isn't such a thing. So we would say can't have, so write this in your notes, can't have negative distance so that we say for this one, there is no solution. No solution to this one, and we circle that. We have to actually say that, we couldn't come up with anything for x. There is no solution. So can't have negative distance, so there's no solution. Okay, anybody have any questions so far? Any of this, like what we talked about so far, confusing? Okay, then let's move on to, now notice what's different in this one. There isn't just an x alone in between those absolute value bars. Our expression isn't just x, our expression is x plus 3. So that's a little bit different. We have to treat this a little bit differently. So this is asking which numbers can x plus 3? That's our expression. What can x plus 3 be that are 5 units from 0? So what we're going to do is we're actually going to take, just like we took the expression that was in the absolute value bars and set it equal to any numbers that had that distance, we're going to do the same thing here. So basically what we're going to do is we're going to take that x plus 3 and we're going to set it equal to any numbers that you know are 5 units from 0. Are there any numbers that are 5 units away from 0? Positive 5? 5 is?
-5.
And so is negative 5. So we can set the x plus 3 equal to 5, and we can set the x plus 3 equal to negative 5. In other words, we can set that expression equal to any number or numbers that have a distance of 5. So now what we have are, we have two equations to solve. So we'll just do our simple solving here. What do we have to do to get x alone? Subtract 3. So we end up with, for this one, we end up with x equals what? 2. So there's one of our solutions. And we'll come over to the other one and do the same thing. We'll subtract 3 from both sides. What's a negative 5? Take away 3. Let's change this to add the opposite since there's all these negatives and stuff involved. What's a negative 5 plus negative 3? Negative 8, right? So notice this time we don't have numbers that are opposites of each other. Like up there we were 7 and negative 7 and 12 and negative 12. This time, because x wasn't by itself to start with, we ended up with different solutions that are not opposites of each other. Now, what we are going to do is, you don't have very many problems to do because I want you to do a check problem. I want you to make sure that you got good answers. So, what you're going to do is we would start with our x plus 3 in absolute value bars equal to 5. And since we got two solutions, we're going to have to do it twice. So go ahead and write it down twice. We're not solving, so we don't make that a negative 5 here. We're just checking. So we use the same equation twice because we have two solutions. So now what we're going to do is we're going to substitute in for x. We're going to do our first solution, which is 2. So we just put the 2 in place of the x. Everything else stays the same. We're not solving. We're not doing something to both sides. We're substituting in. And now we will say, now we will bring these together because we can. Our absolute value bars are still there though. What is 2 plus 3? 5. So we end up with the absolute value of 5 equals 5. And what this is saying then is, how far is 5 from 0? 5 units. the absolute value of 5 is 5. It is 5 units away from 0. And the other side says 5. So is this true? It does 5 equal 5? Yeah. So it checks. So we ended up with the absolute value of 5. It's asking us how far away is 5 from 0. That's what absolute value means. It is 5 units away, so it checks out. Now let's do our other solution. We say that the other solution is negative 8. So we'll substitute our negative 8 into the x. And then we'll say, what is negative 8 plus 3? Negative 5? Yeah. Okay, so now we have the absolute value of negative 5. We bring along the rest of the equation. And now to get rid of the absolute value bars, we ask ourselves the question, how far is negative 5 from 0? How many units of distance is negative 5 from 0? 5 units. So this also becomes 5. And it checks out. So our two solutions, put back in, make the equation true. Now we have to, the thing that you're going to have to make sure that you can keep straight when you're doing this stuff, is you have to make sure you can keep it straight. What am I solving? What do I do then? And what am I checking? And what do I do then? Okay. So any questions on this side before we go practice some more? Okay, let's go to the back side. Okay, it says the absolute value of x minus 4 equals 9. So the expression x minus 4 can be set equal to any number or numbers that have a distance of 9 units. What number or numbers are 9 units from 0? 9 and negative 9. Okay, so what we do is we take the x minus 4 that's in the absolute value bars, and we set it equal to each of those numbers. So x minus 4 gets set equal to both 9 and to negative 9. Okay, so we set up our two, this is how we got rid of the absolute value bar so that we're ready to solve it, and now we're going to do what to both sides of the equation? Now we're solving. What are we going to do?
We would add 4.
Add 4. So add 4 on both sides. X is now by itself over here because these guys take care of each other. And 9 plus 4 is? 13. There's one of our solutions. And then we take care of solving the other one. Same thing, we'll add 4 to both sides. What happens when we have negative 9 and we add 4 to it? What do we get? Negative 5. So we have x equals, because these guys took care of each other, so we have x alone now, and we have negative 5. So our two solutions appear to be x equals 13 and x equals negative 5. Do we have to what? Yeah, you got to make sure you show both solutions. And we do it to show checking. That's why you have so many problems to do. Okay? Any other questions? Okay, then let's go and do our, remember what we do now when we're doing our check problem, we just write down the equation that has the absolute value bars in it. And remember we have to do it twice because we got two solutions. So same equation, twice. We're just checking. And we will substitute in, first of all, we'll substitute 13 into this one. So 13, take away 4. Blake, what is 13 take away 4? 9. So we have the absolute value of 9 equals 9. And then we say, okay, what is the absolute value of 9? Well, how far is 9 from 0? That's the question. How far is 9 from 0? 9 units. So we end up with a true statement. We can say that one checks. Now we put in our other solution, which is -5. So we have -5, take away 4. What is -4 take away? -5 take away 4. Or in other words, we could change this to add the opposite, right? What's -5 plus -4? -9. So we have the absolute value of -9. Absolute value means how far away from 0. So how far away from 0 is -9? 9 units. So it's 9, and bring down our equals 9. We can say got a true statement. It checks. Now, here's what your brain is going to tempt you to do. It's going to be, you know that we got 2 solutions most of the time in the notes, so you get this one, and you say, okay, the other solution is going to be its opposite, -13. And you just say, I don't have to show all that extra work because I already know the other solution is going to be that. I just want you to watch. You do not have to do this in your notes, but I want you to watch what happens if I really check out -13. If I put -13 in for x and I subtract 4, anybody know what -13 take away 4 is? -17. Okay, how far is -17 from 0? 17 units. Is that a true statement? Does 17 equal 9? No. So we would not check out. So we can't pretend and try and shortcut it. We have to make sure that we actually are solving it and finding out what the solutions are and making sure that those solutions do actually check out. Not just, saying, well, I got it done, that's what's important. Okay, what do you think we should do in this one? Okay, but we don't want to do any dividing yet. What's our first move? We got to get rid of those absolute value bars. It says, how far away is 5x from 0? So, it needs to be set equal to any numbers that have a distance of 20. So, go ahead on your papers. That's all I want you to do right now. I want you to write out. I'm going to tell you right now, there are 2 things you can write down that help us solve this. Go ahead and write them down. So in this next step, there would be no absolute value bars. Set your expression that's inside of them equal to any number or numbers that have a distance of 20. Go ahead, Holly. Try it. We're going to erase it. Oh, you just sat here.
Distance of
20. 20. It says 20 here.
But it'd be 55.
No, don't worry about that right now. You need to set the expression that's inside the absolute value bars equal to any number or numbers that have a distance of 20. That's what I want you to try doing. So, there are 2 of them. What's one thing that I could write down here to help me solve this?
5x equals 20.
5x equals 20. And that same expression, 5x, can also be set equal to the other number that has a distance of 20, which Adam says is -20. Now we're ready to worry about that 5. What are we going to do?
You're going to change that x into a 20?
No. What are we going to do to the x alone?
You divide it.
Divide by? Yeah, we're going to divide by 5. Divide both sides by 5. So 5x is going to get divided by 5. 20 is going to get divided by 5. Our 5's cancel out over here so that we have x alone. 20 divided by 5, what is that? 4. Okay, so if you did not have a good setup, you can erase and follow along with us. Because we have to check this also, but we'll wait till we get our other solution. And then the other one, we're going to do the same thing. We're going to divide both sides by 5. And x is equal to what in this one? -4. It does turn out to be the opposite this time. Doesn't mean it will every time, though. Sometimes it does. Now we will go and do a check problem. We will write down that absolute value equation, how it started. And since we got two solutions, we have to do it twice. So the same equation, absolute value of 5x equals 20. We just use it twice because we got two solutions. And we're going to substitute in. So it's 5 times 4. Absolute value bars are still there. What is 5 times 4? 20. So we have the absolute value of 20. This is asking us, how far is 20 from 0? It's 20 units away. So it checks out. Now we try it in this one. We have 5 in absolute value bars times a negative 4 this time. What's 5 times negative 4? Negative 20. So we have the absolute value of negative 20. That's asking us on the left side. What's it asking? How far is negative 20 from 0? How far is it? 20. So does that one check out? That one checks out also, doesn't it? Okay. Questions? Okay. Now, if you're feeling pretty confident, now I'm ready to work ahead. How many of you are feeling pretty confident? You're like, I can do this next one on my own. You got it? Okay. What are you going to do? Tell me what you're going to do in this one. Wait a minute. Don't be trying to hear that one yet until we set up our equation or equations. I want to go back to my grandchildren. They were much happier with me. They like me. You guys don't, huh? Get rid of the absolute value bars. Yeah, okay. So then to get rid of the absolute value bars, we say I can set x minus 1 equal to any number or numbers that have a distance of how much? Negative 3. You see a problem with that?
Oh, so there is no
You
solution.
can't have negative distance, can you? No. So we say, you know what? We just circle that right there and say, can't have negative distance. So just when you thought you knew what to do, they had to go and throw a negative distance in there. And when you have this situation and you can't have negative distance, you say, well then, guess what? There's no solution. And if there's no solution, I can't do a check problem, right? Yes, sir.
So for the problem, all you have to do is put no solution.
You would make, just like we're doing in our notes here, you say can't have negative distance. I do want you to write that part. Can't have negative distance. And then you would say no solution. But you do have to, you can't stop after that negative distance part. You do have to say no solution. Okay? So, sometimes we discovered that we got one solution. That's when it was set equal to 0. Then we discovered most of the time we got two solutions. But then we also discovered, guess what, when it's set equal to a negative number, you can't have negative distance, so that means there's no solution. Okay, so any unanswered questions? Hey, let's get that loose leaf out and get started on homework then.